So start building distributed applications with ease using building block APIs. Before we start, how many application developers are here in this audience? Just a handful, right? So, and a bit more, okay, because I think this session is definitely, I think, for you, but it's also still very valuable if you're more like infrastructure related. But I'll get back to that. So about myself, I'm a senior developer advocate for Diagrid, and Diagrid is a company founded by the two co-creators of the Dapr open source project, Mark Vassel and Jeroen Schneider, and we create some products in the Dapr ecosystem. So for instance, we have like a operational tool if you're running Dapr on Kubernetes, it's called Conductor, and there's a very new tool called Catalyst, and that's like a serverless option of Dapr. I'm also one of the Dapr community managers, and every other week we host a Dapr community call where we live stream to YouTube, and we either invite some end users, some Dapr end users, to explain what their experience is with Dapr, or we invite some of the maintainers and contributors of Dapr to share some news about the latest Dapr features. So if you are a Dapr end user, please come see me afterwards, because I can give you a spot at this Dapr community call, so that would be awesome. About me, I have like many creative hobbies. I like pixel art a lot, as you can see here. I also have some Dapr stickers with me, also in some pixel art style. So if you want to have some stickers, please also come see me. I also like creative coding a lot, and I also make some music with my modular synthesizer. So if you want to know a bit more about those things, you can check out my website, marcduiker.dev. Also, all of my socials are on there. So if you want to follow me or whatever, have a look there. So, okay, we're here to learn how to build distributed applications, and a lot of very big organizations do it in this way, right? So they have like many microservices, and it's probably not really because they want to, because it's really quite hard, because they're sort of forced to do this, right? So they have like many developers across many different teams. They all need to deliver value and work independently, and that's how you end up with all kinds of distributed application with many different individual services. But you do need to think about, okay, how do I actually orchestrate my business logic across these services, right? And how do I deal with tracing across services, and also across message brokers and services? And how do you deal with like access control, right? So which services are allowed to communicate with each other, and which services are allowed to connect to a state store or to publish a message? And how do you deal with failed requests? And what if a service is temporarily offline because of a deployment? How do you deal with these things? So if you're in that situation, you should definitely have a look at Dapr, the Distributed Application Runtime, because it really has been built with all of this in mind, and it takes over a lot of the responsibility, so you don't have to write that code yourself. So is anyone here like familiar with Dapr? Just a few. Okay, now this is then a good session for you, because this is like an intro to Dapr, so that's perfect. All right, so if you're running your applications with Dapr uses the sidecar pattern. So Dapr runs in a separate process next to your application, right? So Dapr is not part of your application, it runs in a separate process. And this has a lot of benefits, because all of the communication that's happening between services, but also between like services and resources, like message brokers, data stores, and so on, all of that communication goes through the Dapr sidecar. And in that sense, Dapr has like full control and visibility of all of the communication. So all of the traces need to go through the Dapr sidecar. So Dapr really takes care of the whole resiliency thing, which I'll demonstrate later. Also observability and also security. So you can use Dapr with practically any language, right? Because Dapr doesn't sit in your own code base, not because it runs in a separate process next to your application. So Dapr exposes an API, actually many APIs that you as a developer can use to build your microservices pretty quickly. So in the middle column, there's a whole list of different APIs that the Dapr exposes. The workflow API is still in beta, but it's quite popular. So you can actually write your workflows as code using Dapr these days, which is really cool. The jobs one is very new. Version 1.13 was released like I think two weeks ago. So there's now a jobs API to schedule all kinds of tasks with Dapr. But in this session and later in the demos, I'll focus on the service invocation API, the state management API, and the PubSub API. But as you can see, if you use Dapr, you have quite a big tool belt with all kinds of APIs and the built-in cross-cutting concerns regarding like security, resiliency, and observability. And most people run Dapr on top of Kubernetes, either like plain Kubernetes, maybe could also be on-premise, or one of the managed cloud services. There are also some specialized services. There's also in Azure, there's Azure Container Apps, which has like part of the Dapr API available. And also Diagrid offers like Catalyst, which is serverless Dapr. The nice thing about Dapr is that the APIs are decoupled from the underlying infrastructure. So what does that mean? Well, with Dapr you have all of these APIs, but Dapr is not a state store. Dapr is not a message broker. Dapr provides these APIs, but you can configure Dapr to use many different state stores or many different message brokers. And that really makes Dapr like super flexible. So just an example of how you can like build some systems using the Dapr APIs, and I'm just showing the HTTP APIs here. So for instance, you can trigger an application using a Dapr input binding. You can then use the Dapr secrets API to retrieve a secret from a secret store. You can use the service invocation endpoint to post to a different message. You can use the configuration endpoint to read some configuration values. You can use the publish endpoint to publish a message to a message broker. Other applications are then subscribed to that message broker. And you can use the state endpoint to persist, say, some key value state. And you can use an output binding to post something else to a different service. And note that all of these are Dapr APIs, so these are not like resource-specific APIs, right? So these APIs that we're using are not tied to a specific PubSub message broker. It's not tied to Kafka, not tied to Redis, not tied to Azure Service Bus. It's the Dapr publish API, and by configuring with component files, YAML files, I'll show an example later, on that level you actually define what kind of underlying resource you're using. So the nice thing about this component model is you can swap out the underlying configuration. What I really like is if you can use local components for local development, and when you switch to a different environment, then you switch to different components, and all of the application code stays the same because you're using the Dapr API, which is like an abstraction across all of the other resources. So when I'm doing local development and you have like these three services, then I can use a local file for some secrets. Just make sure that local file is not checked into source control, of course. I can use like a local Redis container to do PubSub, because when you install the Dapr CLI locally, you also get a Redis container. And I can use like an in-memory state store component. But when I push to production, then I can switch out these components files, these YAML files, and then I can use like Azure Key Vault, Azure Service Bus, Cosmos DB, without changing any application code. And the same is true for like different clouds, right? For AWS, we have components. For GCP, we have components. And also for other types, we have different components. So it's super flexible. Not a lot of people do true multi-cloud solutions, which you, of course, can do with Dapr. But I think only a very small percentage of organizations are actually doing that. But I think it's great if you just move from one environment to the other and then switch components. So Dapr's been around for 5 years now. In October, Dapr will turn 5, so there will be like a special event. There will be a virtual conference, Dapr Day. And over the years, we have like many contributors for Dapr. Diagrid is definitely one of the biggest now regarding contributors. But we have like many big organizations contributing to Dapr, which is great to see. Also regarding Dapr end users, also a lot of big names there, and definitely some cloud providers in there, but also across many different verticals, right? Okay, time for some API demos. So let's start with the service invocation API. It's the most basic one you probably want to use. So that's used for like synchronous communication, right? You make a request and you get back a response. How does it work? Well, normally, if you do like service invocation, you make a request from one service to another service. So in this case, we want to call the order service on the checkout, and we do that from the customer service. With Dapr, we then create an URL like this. We use the invoke endpoint, and then we specify the application ID of the target application. In this case, it's checkout, and then /method, and then the order method that you want to call. But we're not making a direct call from one application to the other. So what actually happens is our customer service is targeting the Dapr sidecar. and the Dapr sidecar will then look up what the address is belonging to this checkout application ID. And once it has find the address, then it will forward the call to the corresponding Dapr sidecar for that service, and that Dapr sidecar will then forward the call to the checkout service. And then the logic happens in the checkout service, and then a response will go back the same way. This all happens very quick, right? So there are a lot of lines. You think, ooh, this might be a bit slow, but I think on average, I think it might be some 5 milliseconds latency because of these sidecars. So there's not a lot of overhead that happens here. Let's not do this sample code because I have some live demos for you. Right, I'm using VS Code. I'm also having a lot of extensions in VS Code. And one of the extensions I'm using is called Code Tour. And with Code Tour, you can give some kind of a guided tour through your code base, including like text and images. So what we're seeing here is part of the Code Tour that I want to show you. So I'm going to show you service invocation, but I'm also going to show you the built-in resiliency policies in Dapr. So what happens if a service is temporarily not available? Well, then the Dapr sidecar actually will retry a couple of times to make sure that call will actually happen. So we got this situation. Application A will make a call to application B, and application B will store some state in a key value store. And I'm all running this locally, by the way. So these samples are in .NET, but like I mentioned, you can use Dapr with any language. So this is based on .NET 8, and this is our program CS file. So we're going to make an HTTP request to another service, and we're going to use the .NET HTTP client for this. And I've registered this HTTP client to actually create a specific HTTP client that contains a specific header. So application IDs are really important in Dapr. So every application has an application ID, a Dapr app ID. Especially when it comes to service invocation, then you need to specify what is the application ID of the target service that I want to make the request to. So when you see this, there's like a helper method on the Dapr client called create invoke HTTP client, and there I specify what the application ID is. So everywhere where this HTTP client is injected in the code, it will have like a sort of prefix with this header that I'm always targeting application B. So this is the endpoint that I'm going to call very shortly. It's called /service invocation. This of course can be anything you want. I'm giving it a payload called social profile details. This HTTP client will be injected that has the application ID set to application B. And I'm going to do a post to the /profile endpoint and providing it this payload. Then do some console write line and giving back a created result. If you look at the target application, this application B, it's the same .NET type, and this is the program CS file here. The thing what's important here is this will communicate with a state store, and note that I have this constant here, state store component name, and it has a label called my state store. So remember this because we will see this somewhere else. So this is the /profile endpoint that we're going to do a post to. The Dapr client will be injected here, and we use this Dapr client to save a state object. And the state management API is a key value pair API. So what happens here is I'm providing the name of the component, my state store, and then I'm specifying a key, which is the profile ID here, and then the value itself. All right, but as you noticed, it's called like a Dapr client.saveState, right? So there's no mention of a specific state store, right? So in this case, I'm using a local Redis container to store the state. But in the application code, it is completely unaware of the state store. So how does Dapr know what type of state store is used? Well, this is specified in this component file. So there's this statestore.yaml file. That's being loaded as soon as we start the whole Dapr process. And that contains the same label as our application, right? It's called my state store. And in this file, that contains the actual underlying type of the state resource we're using. So in this case, we're using state.redis. And then for each different type of connection, there's always some kind of information in how to connect to it. All right, so I'm going to run this sample locally now, and since I think Dapr 1.12, there's a thing called Dapr multi-app run. It's of course quite common that you want to like run multiple applications, multiple services in one go. And since Dapr multi-app run, you can now configure all the applications that you want to start in one file, in this dapr.yaml file. So this contains a list of applications. In this case, we have two applications, application A and application B, each with their own ports. And I'm also referring to a resources path. And the resources path contains the state store information. So that loads the component file that defines that we're using a Redis container for our state. All right, so I'm running that. So application A is building, application B is building. The logging is quite verbose, but I do it intentionally so we can have a look what happens when things go wrong and the resiliency kicks in. So now both my applications are up and running. So now it's time to make a call to that endpoint. I'm yet using another VS Code extension called the VS REST client extension. And if you use that extension, you can add these .http files or .rest files to your Git repo. And in there you can define like variables and create your endpoint definitions like this. So now I'm going to make a call to my application A URL to /service with this payload. And as you can see here, there's a link here, send request. It's a sort of button. And when I click this, I'll make a post request to the service verification endpoint with this payload. And this means a new random GUID will be created each time I click this send request button. So the request will be, the response will be available on the right-hand side. So when I click this now, we get a response to one created. And we see in the logging that application B saved the state to store, and application A has sent the thing to application B. So this is the happy path, right? This is service verification. All right, but the happy path is a bit boring, so let's break it now. So now we're going to simulate an issue with application B. So what we're going to do is, instead of using the Dapr multi-app run to start both applications, we're just going to start application 1. We're going to make the request to application 1, and we wait a couple of seconds, and then we're going to start application B to simulate that it was maybe a network issue or maybe a slow deployment, that application B was not already available. All right, so here I'm going to start application 1. So application 1 is running. Here I will navigate to application B, and I will also copy the command to run it, but I will not run it just yet. All right. So now I'm going to make the same request, the service verification request, to application A, which is running, but application B is not running. So let's see what happens. Okay, make the request. We don't see anything appear on the right-hand side, right? So there's no response, which is correct. And we can see here in the logs, error processing operation endpoint retrying in 2 seconds. So this is the Dapr sidecar kicking in that is going to retry the request for actually quite a while. So now I'm going to start application B. Okay, application B is up and running, and now that we get the response back, right? So thanks to the built-in resiliency policy in Dapr, the request finally got through, and we got a response. All right. Okay, so how does this work? Well, Dapr comes like built in with all kinds of defaults for resiliency policies, but you can override them if you want to. So if you have very specific rules, and I want to retry this so many times, or I want like a constant back off or like an exponential back off, you can actually configure that. So I'm now in another file called resiliency.yaml, and that contains a resiliency configuration for Dapr. And like I mentioned, you don't need to use this if you're happy with the defaults, but if you want to override the defaults, you can actually use this file. So you can see here that it's a kind of resiliency configuration, and that contains a specification that contains some different things. So there are policies here. There are retry policies. I'll skip this one for now. But in this case, the service invocation is using this policy. So I created this myself. It's called my constant policy. So this is also a constant interval of 2 seconds each. And max retries -1 means just keep going, keep retrying, and just never stop, which is useful for demos, but otherwise maybe not so useful. You can also configure circuit breakers as well. And the other part which is very important is the targets part. So the first part was specifying the policy, but the targets part is where do you want to actually apply this policy to. So there are like two different sections here. There's applications. You can apply a policy to an application. In this occasion, I'm applying it to application B, and then the retry policy is my constant policy. But I can also apply it to components, and we'll see that later. You can also apply it to state stores or to pub/sub components. All right, let's move back now and go to state management API. So state management API in Dapr is key value pairs, and it sometimes we should actually rename it because the key value API would be a better name for it, because sometimes people think, okay, we have this state management API and I can do all kinds of complete like SQL statements and stuff like that. Unfortunately, that's not the case. So it is limited as a key value pair API. All right. So what happens with the key value pair API? Your application has some methods like I already showed you, like a save state and get state and delete state and so on. But again, there's a Dapr sidecar in between, right? So your application is not talking directly to a state store. Your application is talking to the Dapr sidecar, and the Dapr sidecar knows which state store to talk to because there is this state component file. And again, it's key value store, right? So you need to provide a body with the key and then a value that contains the object that you want to store. And what's also important to realize is that the actual key in the storage will be a combination of the application ID, so the Dapr application ID, so that's orders in this case, and then a double pipe symbol, and then the actual key. So if you persist some state with the same key, but in different services, so application A and application B, that will result in a different global key, right? Because one will be app A order one, and the other will be app B order one. So the default is that every service has its own sort of namespaced state by application ID. You can, if you want, share state across services, because then you can override this configuration in the state the state management component file by actually removing this application ID part. And if you want to retrieve state, you specify the key. All right, let's do another demo. So that involves a state store, but that also involves some resiliency again. So what we're going to do, first we're going to just make the call, and then we're going to actually simulate an issue with the state store itself. So now I want to show you this. So there are many different resiliency policies in Dapr, and there are many different types of policies, also for the different APIs. So there is this thing called the default state store component outbound retry policy. It's like very verbose, but also very, very explicit. So if you want, you can override this specific retry policy. So that's what I've done here. So instead of like doing this and creating your own name and applying that, you can also override one of the default retry policies. So in this case, I've used the same arguments as the constant policy. So it's a contents one. Every 2 seconds, it will be retried, and we're going to retry indefinitely. And yeah, I'm not going to do the happy case because we've already seen the happy case. So let's run both applications now, both app A and app B. So it's the same demo as before. So applications are running, but now I'm going to stop the Docker container that runs Redis. All right, and I will copy this here, but not run it yet. So now I'll make the same call to application A. Application A will do a service verification call to application B, but then application B cannot reach the state store because the Docker container is not running. So let's see what happens. All right, making the call. We don't see any result here, but we do see again error processing operation component my state store output, right? So it identifies that there's an issue with this my state store component, and it's retrying again in 2 seconds. So now let's start the Docker container again, and now we see that the call has succeeded. right? So again, you see that the Dapr resiliency is kicking into place. And what we can also see actually that in the logs, how many times it took to actually recover, right? So recovered processing after 6 attempts. All right, let's go to the final demo, and that's the PubSub API. So PubSub is, I think one of the most popular APIs in Dapr. It's used for like asynchronous communication, right? We have a service, the publisher, that publishes a message on a topic, on a message broker, and there's at least one other service, but most likely more, that are subscribed to the same topic. So in this case, there's always a message broker involved, but since you're using Dapr, you only use the Dapr PubSub API, right? And you're not actually tied to any specific implementation of a message broker. So the message broker can be anything. You use this API, the publish endpoint, to put a message on a topic. So in this case, you specify the name of the PubSub component. So it's called my broker, and this is then the name of the topic or the messages. And finally, there need to be like an endpoint in your target application that handles that message when it's received, the message. And of course, since it's Dapr, there are Dapr sidecars. So what actually happens is you actually make a call to the Dapr HTTP endpoint, and the Dapr sidecar will then actually push the message to the message broker. The other Dapr sidecar is subscribed to that topic, and that will actually forward the call to the endpoint that you specified. This is how you configure it. And let's see the actual demo. Here we go. So now with the message broker, there's actually 2 types of resiliency that you can configure. So there's an outbound resiliency policy, which is the same as the state store resiliency policy, because that goes outbound from your Dapr sidecar to a resource. But there's also an inbound resiliency policy, and that goes from the Dapr sidecar back to the application. Right, so this is the PubSub endpoint that I'm going to call in a couple of seconds, and we're using the Dapr client, and then we use the publish event async methods to publish a message to a PubSub message broker. We specify the name of the PubSub component, so there's a PubSub YAML file here that contains a configuration of what the actual underlying PubSub is. The profiles is then the name of the topic, and this is then the payload. All right, now I need to rename a couple of files. I'm going to do that. And this one. Okay, so this PubSub YAML contains the actual underlying resource definition of the PubSub component. So in this case, I'm using Redis again as a PubSub component. And the other thing is a subscription. There are different ways Dapr can deal with subscriptions. You can either do it declaratively, that's in using this YAML file. So then you can specify, okay, what is the name of this component of the subscription, what is the topic, what's the endpoint that needs to handle the messages, and what's the PubSub component name. You can also do it completely programmatically, declaring this subscription. And with Dapr 1.14, you can also do like dynamic subscriptions. So you can actually define all of this at runtime, which is pretty cool. Okay, I've shown this. Yes. Okay, so let's run both apps again, because I'm using the same 2 apps. All right, so they're both running now, and so now I'll do the same thing. I will stop this Redis container again, because Redis both acts as a state store, but also as a PubSub component. And as soon as I now stop this, we will see the subscriber application complaining. So there will be a lot of errors thrown because it's no longer actively subscribed to this topic. Oh, here we go. So there'll be loads of errors, but that's fine. Now we can actually call the other endpoint that will actually make a PubSub message to application B. So here we go. But again, the application is the component is not up and running. So let's actually start this again. So now the Redis container will be back. And now we see that the PubSub actually succeeded. So again, another example of PubSub or of components and retries. All right, the final thing I want to show before the closing slides is if you're really serious about making your Dapr application really production ready, I can definitely recommend you this free tool that you created. It's called Conductor Free. It gives you some nice overviews of your application, how everything is like communicating with each other. But the most valuable thing, I think, is this advisor. So it scans all of your Dapr component files and configuration files, which I've just shown you, and it gives all kinds of recommendations based on all of these files. So it really helps you to get your production readiness to the next level. There's also some component builders here now, and also a resiliency builder, so you don't have to craft all this YAML yourself. So that's also pretty nice. All right, final things. Whoop. Okay, so I've now shown like a bit of an overview of what Dapr can mean for you if you want to build distributed applications on top of Kubernetes. I hope this was like a good short overview, and maybe a bit too short. Dapr offers a lot more, many more APIs, but luckily there's like a lot of information out there on the website. So definitely check out dapr.io. There's also a Dapr Discord where all of the maintainers and contributors are. So please also feel free to go there. If you want to run the code samples yourself that I've shown here, check out this left QR code that points to a GitHub repo. If you want to know more about this Distributed Conductor service to increase your production readiness, please check out the other one. And finally, thanks for your attention. And if you want, you can claim this Dapr Community Supporter Badge. It's a digital badge. It's not an NFT, hosted by the nice people from Holopin. I've created lots of different badges for Dapr. So also, if you're like contributing to Dapr, you can also get these badges. But this one you can just get by just scanning this QR code and just listening to me rambling about Dapr. Any questions?
Please give a hand for Mark. And very informative talk. Thank you very much.
Cool.
Are there any configs regarding API behavior that should still be defined in the app, even when using Dapr? So some escape hatches and custom config.
So the API is really the same for whatever you're using. And so if you're doing a PubSub with, for instance, Kafka, or you do PubSub using Redis that I've shown you now, or doing PubSub with Azure Service Bus, the API is the same for all of it. But what you configure in the component.yaml file, that is of course different, right? So for Kafka, you have to specify many more things. You can definitely have like more control over the behavior over the PubSub system in that component YAML file. Mm-hmm. So not on the API level, but on the component YAML level. Yes.
Okay, so I cannot go cowboy and change stuff just for one single request. It's
no, exactly. No, indeed.
Yeah,
no,
it's also discouraged.
Yeah,
probably.
exactly. Yeah, indeed. Yeah.
All right. Footprint of the Dapr sidecar container, if you have a number.
Oh, that's a good point. I think it was like 60 megs or something. But yeah, that's straight out of my top of my heart. I don't know the exact number, but I don't think it's that big, to be honest. Yeah, there are actually different solutions now, because some people don't want like a sidecar next to every service. There's also a lot of concept thing. It's called Dapr Shared. That's now also part of the Dapr GitHub repository, and that uses a Kubernetes deployment or a daemon set to host the Dapr process instead of like a sidecar for each service. So there are like some different flavors that you can try.
Yes. Yeah. Please answer this one, and I will get more questions in front of you.
How does Dapr behave if the app that uses certification has context timeout that are defined lower than Dapr retries? Oh, so if the timeout already happens, that's a good call. I never tried that. Yeah, whoever has that questions, please feel free to come to me anytime, and we can just try it out, or have a chat on the Dapr Discord and let's try it out. Yeah, it's a good point.
Are you getting some free stuff? So when you integrate, do you get like MTLS between services or error rates and stuff?
Yes, exactly. Yeah, exactly. Yeah, I did not need mention it explicitly, but yeah, that's what you get out of the box. So that's also one of the nice things why a lot of people like use Dapr because of the MTLS. Yeah, yeah, good point.
Cool. I have 9 more questions in Slido, and I will select just 2, and then I think Marc will be around, and you are also having a larger break until 11:10, so you will have time to ask Marc.
Yeah. I also have lots of stickers, by the way, so if you want some Dapr stickers, please come and get them.
Yeah, it's interesting. So how would you compare Dapr with like a service mesh solution?
Yeah, so there are like some similarities, right? So for instance, how you can like how you do like service discovery, for instance, right? So although the implementation is a bit different, but yeah, some people like compared with that. But service meshes really operate on like the network level, and Dapr is really more for the application level, right? So yeah, if you want to do like, for instance, routing, stuff like that, then something like a service mesh is ideal because Dapr cannot do any routing. And yeah, where Dapr really shines is because it's offers all kinds of these building block APIs, right? So that's not part of a service mesh. A lot of people use both Dapr and a service mesh like Istio together. So that's so you get the best of both worlds.
Makes a lot of sense. And then just one last one, which is just your experience. How is integration usually happening? Is it quick, like all services rewrote, or over a course of time or period?
You can go very, very slowly, right? You don't have to go like all in and install Dapr and have sidecars for all of your services. You can just try it with just 1 or 2 services and see how it goes, and then gradually continue. Because you annotate your services to actually use a Dapr sidecar. So you can just provide the annotation for just the couple of services that you want to try first, and then gradually continue using the Dapr. Yeah.
That makes sense. Thank you very much, Marc. Please, another
thanks.
hand. And